So for the graphing, I'm not gonna force you to graph, but I do want you to be able to determine what each graph looks like the sine graph, cosine graph. The main thing I would want is, can you give the period and can you give the amplitude of a graph? Okay. Let me find the question real quick. Okay, so given a function y equal to a sine bx minus c, and y equal to hold on a sec. Let's add the d right here. Plus d, and y equal to a cosine bx minus c plus d, where a, b, c, and d are real numbers. Sorry, some students are still entering the class. Okay. Let me give you all the formulas here. So A is the amplitude. C divided by B is the phase shift. D is the vertical shift or translation. Let me find the formula for period. That's the only one missing. Where is that guy? Oh, here it is. Yeah. Period is equal to 2 pi divided by B. See if I need it. My pen's all right. This thing is this notebook. Need another new one. All right, let's pick a question. So I'm gonna show you what I expect like on the test. I don't want like to get too in depth with graphs just because yeah, technology and we have other approaches. All right. All right. Oh, here we go. Number 5 is good. Let's get started. Come on, pin. Stupid pin. Find the amplitude and period of y equal to 3 cosine 6x. So looking at this, what do you think is the amplitude?
3.
Yeah, it's just a 3, right? So A is equal to 3. The period, well, let's write it out. I should say amplitude. Amplitude is equal to A, which is equal to 3. Period will be equal to 2 pi divided by 6, which is equal to pi over 3. Any questions on how we found it? Let me show an extra step here. Right, not too bad. Okay. Let me show you the homework. So basically the next one, same type of deal, right? Except you divide by a fraction, and here the amplitude is negative, but you always take the absolute value. So I should add the absolute value to the formula real quick. Over here, they want you to kind of compare them in general. So what happens if I'm multiplying by 3? Well, you're speeding it up 3 times as fast, right? So that means it'll finish the period in 1/3 the time. Okay, so if we graph them, so let's say we have y equal cosine x, that's the original. So at 0, we plug it into the unit circle, we get 1, right? At pi over 2, you get 0. At pi, you get -1. These are all numbers from the unit circle. Now, if you put 3x, you can see that the period, right? Let me make sure you see how it starts over. We should know at this point that the functions repeat themselves over and over again. So from 0 to 2 pi, it starts over. That is one period. See, same values, and then it starts again. Right? 2 pi to 4 pi is another period. So it goes up, down, etc. So the 3 cosine, it finishes 3 times. So 1, 2, 3 before the original finishes. You see that? So the period is shorter because it's 3 times faster. So that's basically what they're talking about here. Okay, so they just want you to remember the transformations, right? The original cosine and sine. If I were to scale the amplitude by 3, see the amplitude now is telling us it goes up to 3 instead of just 1. So the max and minimum values for cosine is 1 and -1, but if you put a 3 on the amplitude, well, it spikes by 3. Okay. So these are all ideas of transformations that we talked about in college algebra. A negative reflects the y value, right? This creates a shift, stuff that you've seen before. Okay, and they started combining the ideas together. This is if the number is outside, it's a vertical shift. Remember when you did all that stuff with parabolas doing transformations? All that is the same deal, but you're doing it to sine and cosine. So here it says sketch the graph of the function 2 sine. So if you remember what the original looks like, we know it goes through here, but it's times 2, so it should be scaled by 2. So the amplitude should be all the way up until 2 and -2. So it has to be this one, 2 and -2. It didn't shift upward because there's no D outside. It didn't shift horizontally either, so it has to be option C. Just by understanding the transformations and what these do and what the original looks like, right? Sine, cosine, etc. Any questions on these ideas so far?
Got it.
Okay, here's 1/2. So it's going to slow it down, right? So like this one sped it up when we put the 3 in here. Oops, that is not right. Input parentheses. See how it's much slower to finish a period? So it's 1 period there. So by the time it finishes 1, the original finished 2. So far you guys are okay?
Yes, the videos actually are very helpful for this section here.
Okay. Nice. Yeah, it's not too crazy, right? I think I'm gonna remove this question. It seems lame. Okay, so that's pretty much it for transformation. So as long as you remember like what scales it, what shifts it upward, to the right, up and down, etc. You should be good. I don't know if they even asked for it yet. Let me see. Yeah, here they have a phase shift. Here they combine all the ideas together. So here's a amplitude of 2, a vertical shift downward, and then a phase shift. So they tell you what the original, what they're doing to the original. You got to figure out what the function will be. That's like just like we did in college algebra. All right. Well, if you have no questions, I'm gonna move on to something else. Just let me know. I don't want to be too in depth with the graphs. 6.5 is basically the other graph trig functions.
So the period for cosecant and secant is always 2 pi, right? Because I think for tan, it's just pi by itself.
Yeah.
Okay.
Mhm. Yeah. So let's see. 6.4. Six five. Let's go ahead and look at them. Yeah, for tangent is going to be pi. So let me write that down here. For 6.5. Yeah, go ahead and write this down. A period, I should just go ahead and write it here for sine and cosine is 2 pi. The period for tangent let's see, and cosecant. Actually, that's 2 pi. One moment, let me double check here. I don't have my notes in front of me. 1 second. Tangent and cotangent. The period for secant and cosecant is 2 pi. There you go. And I'll send you, I've still been meaning to, I need to send you some formula sheets that have all the domain ranges for the trig functions. This so you have everything. I'll do that very soon. By tomorrow morning. So since we're getting closer to exam 1, I'll send a bunch of notes out.
When is
yeah.
exam 1?
I want to say Wednesday we will review, and I'll open the exam up, and I'll give you about over a week, maybe 2 weeks to just get it done whenever. But technically it should be done in about 2 weeks.
Would you send out a study guide for exam 1?
Yeah, we're gonna do a review together. So just focus on those types of questions when we do it.
Will we be allowed to like use like notes or no?
You can use like a formula page, front and
Okay.
back, with definitions, formulas, and a unit circle.
Okay, awesome.
Okay. So for 6.5, really, you just need to know what the graphs look like. And then the same things are gonna happen with the values inside. Like this, we talked about how it's gonna slow it down. So the period should double. So the original period was pi. So if it doubles, then it should be 2 pi, right?
Yeah.
And then you graph the original and compare it, so it shouldn't be too crazy. Does that make sense? Here the 1/2 shrinks the amplitude. So it'll create it'll shift, it'll kind of like stretch or compress depending. And then this will change the rate. So if you know what cotangent looks like, just see the one that transforms. So let's look at the graph here. So if we have 1/2, so that's a cotan, but 1/2 cotan x, kind of hard to see, zoom in. This slightly, I don't know if I can barely even tell if it's stretched. Yeah. Stretch would be the word. Now, if you put a pi in here, it has sped it up. So you should see a lot more of them before it gets to the original. Because it's almost 3 times faster, right? The pi is about 3.14. So just knowing what the original looks like will guide you on these questions. So knowing what tangent looks like will help you figure out which one's appropriate. Obviously, it is not A or B because these are not tangent functions. C and D are tangent functions or close to it. You just got to figure out what is the shift. Or what does this do? Okay. Cotangent, same thing. Only C and B are actually tangent functions. The other two are either secant or cosecant. So these don't even make sense. So here we go, cosecant. So what does cosecant look like? You see how they're kind of like peaks. These peaks actually happen above the sine and cosine. And the asymptotes happen whenever, or at least for cosecant, it happens whenever sine is 0. Right, because remember cosecant is 1 over sine, so it kind of skips those areas and creates the asymptote. Now negative just reflects it, right? Just like the parabolas, you remember back then? So all the ideas of transformations. Turn these off right here. Right, the minus just flips it across the x for parabolas, for any function. So these are flipped. So the black switches spots with the reds. See if you see that. It flips upside down. So obviously it cannot be B or D because those make no sense. You just kind of have to figure out, okay, well, which one is it? Either by plugging in points into here and using the unit circle, or graphing it and understanding transformations. And that should be good enough. But that's pretty much it over and over again. Here they have multiple transformations acting on the original secant. You got a -3, a reflection, a vertical shift, and this affecting the period. So period effect, vertical shift, and a stretch. Anyway, there's not, like, again, like, since I'm not gonna make you do it by hand without a calculator or make me show all those little detail steps, I'm not gonna go too in depth. Does this make sense to you?
So pretty much we're just doing the transformations that we did in the college algebra.
Yeah, everything that you did there will be applied to the 6 trig functions. So all you need to know is what do the originals look like, and then do those transformations.
Okay, yeah, that's good.
But yeah, I mean, that's the exam when we get, well, it's not exam time yet. On Wednesday, I'll show you what I mean, but I'm not gonna be too heavy on graph questions. If anything, they'll be super easy. Anyway, do you guys have any questions on anything? That's pretty much the end for the material test 1.
So we'll be going over the review on Wednesday.
Yeah, Wednesday we're gonna review, and I'm gonna see if you guys have any issues or questions you want to work on. And then Monday I have I will not be available. So on the following Wednesday, I'll check to see if you guys are doing okay. And if you are, then I'll continue a new section. And if not, we can review some more.
Okay, and the extra credit for the review, is that added, like it's its own thing, or is it added to the test?
Let me see. I don't know if I'm still gonna do that. For the extra credit, I think I'm gonna do an ISLO assignment instead. So I'm gonna upload that tomorrow morning.
Okay.
The review, I think, would just be for practice. Practice as many times as you can. But I may just do 5 points, you know, what, let me think about it. Maybe 5 points for each thing would be fair. 5 bonus points, okay? Just remember that the ISO is required, so when I post it, I'm gonna lock out everything else until you get it done. Once it's done, just go back to business as usual, okay? That makes sense.
Sounds great.
So yeah, I'll offer 10 bonus points for test one if you. I hope you get it done. But we'll stop here. I don't have anything else for you today. You guys have any concerns about anything or anything you want to go over?
No, but my Rapundus still doesn't work.
Um,
We went over this, me and you went over a while back, but it's still having the same locked out, requesting a code from you.
yeah, we need to figure that out very soon. Okay. Yeah, stick around after class and see what we can do.
Sounds good.
But if you have no questions, guys, we'll call it here, and I'll help out whoever needs help. If you don't need help, then no worries. And your question, Natasha, I'll post it tomorrow morning. I meant to post it this weekend, but too much stuff happened.
Is this the same ISLO assignment you said when we didn't have class Monday?